You should already have in your notebook these two parts of the Pythagorean theorem. Number one, if the sum of the squares of the two shorter sides of a triangle is equal to the square of the longest side, then what you have is a right triangle. Number two, if they tell you it's a right triangle, you know that the sum of the squares of the two legs is equal to the square of the hypotenuse. You should also have in your notebook the alternate way to say this, which is if a squared plus b squared equals c squared, then it is a right triangle. And if it is a right triangle, if they tell you it's a right triangle, if they show you a picture with that little box in it, or if they give you a problem where you can infer that it's a right triangle, then you know that a squared plus b squared equals c squared. When we have a triangle, we have four different aspects of it we can look at. Two legs, one hypotenuse, or one longer side, and an indicator of whether or not it is a right triangle. Any of these could be missing in a given problem. The first one we looked at had the box absent. We didn't know whether it was a right triangle, and we had to use the Pythagorean theorem to find out. The next one we looked at, we were told it was a right triangle, but the length of the hypotenuse was missing. We had to solve our equation for c and take the square root of the two squares, and we added them together to find c. We also have the last one we're going to learn is the missing leg. Perhaps they tell us it's a right triangle. They tell us the hypotenuse in one of the legs, but they don't tell us the other one. So that gives us the case of the missing leg. Pause the video to copy this down, or copy it down while I read it, to make sure you have it in your notebook. Number one, label all the sides. Number two, substitute values for the variables in the Pythagorean theorem. Number three, square the values you know and solve the equation for the missing variable. And finally, take the square root of both sides to find the length of the missing leg. Here's the example we started with. We know b is 4, we know c is 5, and we know because we set this triangle up that a is going to be 3. But let's say it was missing and they told us that it was a right triangle. We would write the Pythagorean theorem and then substitute in the values that we know here, 4 for b and 5 for c. We do the math, we square the two numbers that we know, we find that a squared plus 16 equals 25. Now we have a two-step equation that we have to solve. We have to get rid of the 16 before we can take the square root. To do that, we simply subtract 16 from both sides to give us a squared equal to 9. We're going to have to take the square root of both sides to find a, and when we do, we find that a is equal to 3. Let's do an example that we can get into your notebook. All right, here's our triangle. You want to draw it in your notebook. It's a right triangle. Here's the indication. They've given us one side. They've given us another. First step, label the sides. The one opposite the right angle, that's the hypotenuse, is C. Short one here is A. We know it's a short one because it looks short, but remember, it doesn't really matter which one you call A or B. This one we'll call B. Now let's use the Pythagorean theorem. A squared plus b squared equals c squared. We know a and c, so we'll substitute those values. Square the numbers, gives us 16 plus b squared equal to 64. And now, to get rid of the 16, we have to subtract it from both sides. It's an equation, remember, so it has to be balanced. Whatever we do to one side, we have to do to the other. Remember the subtraction property of equality. It gives us b squared equal to 48. Take the square root of both sides, and b is going to equal 6.9. Make sure you have this example in your notebook on page 115, okay, so that you will have something to use tomorrow when we go over this in class. All right, let me give you one other example, just so you can see it, okay? First, let me tell you about this. Let's say we know that a squared is 48. When we take the square root, we get a equals 69. But they can also tell us that and give us a choice of one of these four choices. To find out which one it is, we simply have to take the square root of the number inside the radical, multiply it by the number in front, find out which one is equal to 6.9. We'll find out that 4 radical 3, which means 4 times radical 3, is equal to 6.9. That's simply an alternate way to give you a choice of answers, okay, that you might have to pick from. Let's do this example. Once again, label the sides. Opposite the right angle, that's C. Short looking side, that's A. Longer side, B. Then write the theorem, do the substitution, do the math, square root, and solve for B. In this case, B is equal to 23.8.